None of us know what it is.
Know what is? I know you don't. We'll talk about it in a second. Can I re-record this lecture first while you guys work on things you're missing, and then we'll talk about it? Addison, if you could go on your phone and insert the answers that you have, that would be magnificent. If you can't do that, use my computer and log into Schoology, your Schoology, and insert it that way. It's not gonna pop up. It's two separate screens.
So, I'm good.
Yes, baby. You took your test. All right, so we are going to review several things in this moment. The first thing we're going to review is the 3 subatomic particles. 3 subatomic particles. First one is the proton, second one is the neutron, and the third one is the electron. Is anyone bored and want to participate in my lecture? It's hard to talk to yourself.
I'll participate in your lecture.
Come on over. All right, so the proton has a charge of what? The proton is positive. Good job. Positive. The neutron. What's the neutron?
Neutral.
It is neutral. We learned this from the Build an Atom. I'm going to insert a link to Build an Atom in the description box below. All right, so the electron has a negative charge. All right, now here's the pretty cool part. Does it affect the mass of the atom? The proton does affect the mass. It approximately weighs +1 AMU. The neutron also impacts the mass. However, the electron is so tiny, it's almost as if it doesn't have a mass. Next up, we're going to talk about their location. Their location. The proton is going to go to the nucleus. The neutron is also going to be in the nucleus. And the electron is going to be in what we call the electron cloud. What's up?
She said you got another paper?
You want to take it on paper? Yes, I do. Dylan, look, you know what it looks like.
Yeah.
Perfect. All right, now this is your subatomic particles, their charge, their mass, and their location. All right? This is going to get us through pretty much the entire unit. Next thing we're going to talk about is what does an atom even look like? All right? The atom model we're going to be talking about is the Bohr model. And no, it is not boring. Ha! 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 Knee slapper even? Yeah? Uh-huh. So the Bohr model. The Bohr model is going to use all electrons. Okay? It's going to use all electrons. But before we even get to really talk about the Bohr model, and I apologize for even writing it right here, we need to talk about the periodic table and what one of these blocks even looks like. All right, here's my favorite element. It's pretty biased. You know what I'm saying? I just feel like inspired by it. I don't know, maybe it's just the Stanley and my name is Stanley, you know what I'm saying? Like, I don't know. It might just be me. This 95 at the top is called the what? Anybody know?
Atomic number.
Good job. Atomic number. This ST is called the what? This is the element
Symbol.
Good.
The name is
This is a great review, team. The name Stanley, that is going to be your element name. Yes, it is. You want to see something cool? All right. And then 200.97 is called the atomic Oh,
You.
oh. Man, I've done this so many times. Atomic mass. All right. I know, it's tough. I broke it.
The LT, can I just email you my LT10 because it will not let me.
You don't upload a picture of it, just put the score you got in the blank.
It won't even let me do that.
Is it because it's closed?
Yeah.
All right. Can you email me about that real quick or send me a message in Schoology and I'll fix it when I finish recording? All right, now let's take the information we just gathered and let's talk about what that even means. Your atomic number, for our purposes, Igzy, this is not for you, but for everybody else in the world, for our purposes, the atomic number is going to equal both the number of protons. Did he find your test? Okay. And the number of electrons. Okay, for our purposes only. It's gonna be better. The atomic mass is gonna help us find the number of neutrons, because I mean we have protons, we have electrons, but we need to figure out the number of neutrons. So the way we're gonna do that is by using mass number minus the atomic number equals the number of neutrons. Okay, mass. So those two are going to help us be great. So we have the atomic number equals the number of protons and electrons, and the mass number minus the atomic number equals the number of neutrons. All right, make sure you have those down. Can you see that? Not really. All right, let's do this. Yes. All right, got it? Oh. All right, here we go. Oh.
You have to click on
All right, next up, we're going to talk about this thing called a Bohr model. Finally, I mean, I've been trying to talk about it all day. We have the Bohr model. B-O-H-R. This Bohr model, like I said earlier, is going to use all the electrons. All right, so for example, let's draw the Bohr model. Wow, that is way more effective. Let's draw the Bohr model of carbon. Nope. Let's write the steps for it first. First thing you're going to do is find the element on the periodic table of elements. I abbreviate it PTO because obviously it's shorter. On the periodic table, second thing you're going to do is use the atomic number to find the number of electrons. After you do that, you're going to use the period number, which is the row, for the number of energy levels, also known as rings. All right, and then last but not least, oh, that hurt. It's fine. I don't need a big toe. Last but not least, we are going to follow our rules. The first ring is going to get 2. Second ring is going to get up to 8. Third ring is also going to get up to 8 for our purposes. Thank you. All right, let's do some examples. I'm going to zoom. Yeah, I would love.
down.
Oh, I think I'm zoomed in all the way. I think that's my problem. It's okay.
Now just go down.
That's fine there. Here are my examples. Make sure you write the word example. All right, let's do carbon. Carbon. All right, carbon has the atomic number of, what's the atomic number? Well, let's go to our handy dandy periodic table that is going to magically pop up perfectly because I planned this beforehand.
1,
Mm,
6.
yes, it is 6. Oh, that's great. Oh, fantastic. Don't mind me. It's gonna pop up.
Just give it a minute.
The wrong one. Here we go. All right, so if I'm looking on the periodic table, I notice that carbon has the symbol C. Wow, that's effective. Has the symbol of C. So if I'm looking at C, I know that this single number in the corner is going to be the atomic number. So since that is the atomic number, I know that carbon is also going to have 6 electrons. And it's going to have 6 electrons. Okay, atomic number equals 6. So that means that my electrons is going to equal 6. Now I'm going to find carbon and see what period it's on. Now in order to determine the period, I got to look at the rows. This is my first row. This is my second row. So that means that carbon's on the second period, meaning that I'm going to have 2 rings. Okay, cool. Following my rules, I know that the first ring gets 2 electrons, and the second one can hold up to 8. I've used 2, I had 6 total. That means I have how many left? 4. Good job, class. 4. Now, something we talked about briefly, very briefly, is valence electrons. Valence electrons are the outermost electrons. All right, so the outermost electrons are right here. 1, 2, 3, 4. So carbon has 4 valence electrons. Now let's do another example. All right, let's do silicon. All right, looking at our periodic table, silicon is right here. The atomic number is 14. So if I know my atomic number is 14, that means I have how many electrons? 14. Good job, 14, my little puppies. 14. All right. Now silicon, let's see where she is. She's on the 1, 2, 3rd row. So being on the 3rd row, that means I'm gonna have 3 rings. So let's draw these bad boys in.
Perfect.
That was pretty good, I'm not gonna lie. All right, now let's draw them in. I have so many to draw. I have 2 going on the innermost ring because the innermost ring can only hold up to 2. I have 14 electrons. I used up 2, which means I have 12 left. I cannot fit all 12 on that second ring because my second ring can only hold up to 8. Why?
I gotta go see somebody.
Add
No, I'd rather you didn't.
There you go.
But go ahead, Dylan. Go ahead.
And then add 1 on the 3rd.
All right, so I've used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means I have 2 left over. Oh, that's not right, Miss Stanley. Silicon is
4.
I should have 4 left over. What did I not count right? Silicon is 16, isn't it? No, that's sulfur.
Silicon is 14.
Why can't I count?
Add 1 on
Because I
the
subtracted 10. I should have subtracted 8, leaves me with 4. 1, 2, 3, 4. Wow. So valence electrons,
4.
I have 4.
Bada bing, bada boom.
Bada bang, bada booba. All right, take this time to draw these 3 as Bohr diagrams. These 3 elements as Bohr diagrams. All right, the elements we're going to do are neon, magnesium, and chlorine. Great, let's check your work. Neon is in the second period, which means it has 2 rings. Neon, knowing that it's in the second period and it has 2 rings, we look at that atomic number. The atomic number of neon is 10, meaning that's how many electrons I put in. We got 2 on the first row and 8 on the second ring. And I'm finished. Valence electrons equals 8. Awesome work, team. Good job. You aren't serious.
Oh, that can't.
What? No, of course, yes, right.
Thank you, Ms. Dennis.
Thank you.
All right, magnesium.
Thank you, Ms. Dennis.
I love you. You stress me out. All right, magnesium, here we go.
Gotta be.
Magnesium is on the third period, meaning I have 3 in my recording that I'm recording right now that can hear everything in the room. 2 go in the center one. 8 are going to end up on this second ring,
Oh.
right? And then left over, I have 2. Thank you. Chlorine. Now's your chance to re-understand this if you don't understand what we're doing here. Now's your time. Chlorine has 17. Ta-da! Check your work. Yay, that's a Bohr diagram. Now that you understand that, let's make it more complicated.
No.
All right.
Yay. No. My camera's not working.
All right, here we go. Lewis diagrams. Lewis diagrams are a little bit different because they only use valence electrons. Okay, they only use valence electrons. Valence electrons are the outermost electrons. Valence electrons are the outermost electrons. Valence electrons are the outermost electrons.
You're gonna shake your brain and be very confused.
Right?
Coming off, man.
Basically. All right, so here we go. We're going to talk about carbon. No, we're not. We're going to do the steps first. Number 1, you're going to find the element on the, hey baby, P2. Then you're going to, use the group number, also known as the column number, to determine, that's fine, to determine the number of valence electrons. You good? Y'all just finished up? All right, determine the number of valence electrons. All right, after you do that, next note about this one, cover the 1. We'll talk about that in a second. And then my favorite part, dot, that, bang, up. Or in a more gentle state, place dots around symbol. All right, got it? Bottom maybe beneath it. Here we go. Start some example problems. Alright. For example, if I have the element, make sure you title this example. If I have the element carbon, hello. I have the element carbon. Okay. Let's use the periodic table to determine what group it's in. Carbon, it's right here. It's in group what? Good job. Because it's in group 14, I'm going to cover that 1, and that tells me that I have 4 valence electrons. Now that I know it has 4 valence electrons, I'm going to assign the dots around my carbon in a box. Now, what is that going to look like? Watch closely. 1 here, 1 there, 1 there, 1 there. Here's the deal. Do not draw your circles like this. That is bad. No. Wrong. Okay? Don't draw them open circles. Just draw them stuck. It is a pet peeve that makes no sense to others, but all the sense to me. Next up, let's do silicon. Silicon is in what group number? Silicon is in what group? It's in group 14. How great is that? Do you see it? It's right here. You go up to the group number because groups are columns. It's in group 14. Wow. It's in group 14, and that means that I cover the 1, and I'm left with 4. That's how many dots my silicon Lewis dot diagram gets. Whoa! Last but not least, let's do lead. PB.
Jelly?
Okay. What group is PB in?
Jelly.
Right? It's in the group right here.
14.
What group is that?
14.
14. Interesting. That means it has how many valence electrons?
4.
Good. 1, 2.
Whoa.
3, 4. Now that's pretty interesting. Carbon has 4 valence electrons. Silicon has 4 valence electrons. Lead has 4 valence electrons. What's a summarizing thought? What's the similarity between carbon, silicon, and lead? Let's look at the periodic table. Carbon, silicon, and lead are all in the same. Good job, Dora the Explorer. It is group. They're in the same group. So seeing as they're in the same group, they also share the same. Don't forget that you're really close to the microphone, so when you talk, it picks up on the microphone. They don't hear me. So they're in the same group. So a summarizing thought would be this. All right. Elements. That's disgusting. Elements in the same group have the same number of valence electrons. All right, now that right there should get you relatively caught up for Unit 2, I think. Did I miss anything? I feel like I did. I feel like that was about it. I think that's it.
I don't know.
That's good enough. All right. Great times.